Hi, in this video we will introduce DAQ and how we will use it in LabVIEW. My name is Hans Petter Halvorsen. I work at the University College of Southeast Norway. For more information, see my blog here. What will you learn in this video? We will give a short introduction to LabVIEW. What is DAQ? We will learn to use the TC01 thermocouple device in LabVIEW. We will learn to plot data from the DAQ device, and we will log the data from the DAQ device to a file. We will also use a measurement filter to reduce noise. Software needed, of course we need LabVIEW. The latest version is LabVIEW 2015. We will also need to use the NI DAQ MX software, which is a hardware driver for hardware used with LabVIEW. In this case, we will use the TC01 thermocouple device. Hardware, in this video, we will use the NI TC01 thermocouple DAQ device. For more information, you can click on this link to see more information about the device. And so, what is LabVIEW? Well, LabVIEW is a graphical programming tool which can be used on any platform from Linux to Windows and Macintosh. It's easy to use, and we can program different systems for it, real-time systems, etc. We can simulate systems. We can use textual programming in addition to ordinary LabVIEW programming. Here we see some hardware we can use together with LabVIEW. In this video we will only use this TC01 DAQ device. Are you interested in more training about LabVIEW? You can visit this website. So, what is DAQ? Well, in this example, we will focus on this DAQ device, which is just a temperature measurement device. While all the devices is more popular, like this USB 6008, where we have analog inputs and outputs and digital inputs and outputs. Here we see an overview of how DAQ is working. First, number one, we have the signals from the real world. It could be analog signals from different kind of sensors, and these values need to go through a DAQ device. In this case, we will use this TC01 DAQ device. Next, we need to have this driver, in our case, this DAQ MX driver. And four, we need to create a program that can get data from the sensor. So, how can we use this device, TC01, in LabVIEW? First, we need to connect the device through the computer using the USB cable. Also note, we need to have this DAQ MX driver. First, when we plug in this device, this window will pop up. So we will try this in practice. Now we have plugged in this DAQ device. If you go into the file explorer, you see you can find it here in the file explorer, and then you can click this TC01 launcher. Then this window will appear, and here you can see the temperature. So when I squeeze the temperature node, you will see it will increase like this. You can also click here on examples or the temperature logger. So here it's a program that logs the temperature from the device to a file here, or we can also see a plot of the temperature here in a chart like this. we can, in order to start the logging, we can click this button. And we can click stop logging when we are finished. Next, we can open the so-called Measurement and Automation Explorer, which is a tool to test and configure the hardware that you use within LabVIEW. So let's try that. Now I'll open the Max tool. You can go here under Devices and Interfaces, and then here we can see our device. Here we can run a self-test to make sure the device is working properly, like this. In this case, you see we get an error message. This is because the device is already used in another tool, this logger, so we need to turn this tool off, and this one, turn it off, and then we can make the self-test once more, and then you see the test runs successfully. Now next, we can use the test panels. Here we can test the device. Here we can make the channel, and then we can start, and then you see we get values from the sensors inside this chart. Can also stop it. Finally, we will learn how to use this DAQ device within LabVIEW. Here in this slide, we see the DAQ MX data acquisition toolbox, or the palette in LabVIEW. In this example, we will primarily use this DAQ assistant. When we open the DAQ assistant, we will go through this wizard. In the first wizard, we need to select if it's an analog input or an analog output. In this case, it's an analog input. And then we just, in this case, select the thermocouple. And then next, so here in 1, we select the thermocouple. 2, next, we need to select the channel. In this case, this DAQ device has only one channel, so we select analog input 0. Then next, we need to set some properties. We can set the mean and max temperature range, and we can also set the units. In this case, we will use degrees Celsius. Also important to set this one to one sample on demand. In addition, since this is a G thermocouple type, we need to select J, and you can also use this, set this to built-in. Yeah. Next, we will create this simple program in LabVIEW to see how it works. Okay, now we have opened the LabVIEW and empty block diagram. Then we can right click on the palette in order to find this measurement IO DAQ MX palette, and then here in the bottom we find this DAQ assistant. So we click on it and place it on the screen. Then this wizard is popping up. In our case, we need to select acquire signals, analog input, and temperature, and in our case, thermocouple. Then we select the proper channel. In this case, it was only one channel, and we click finished. Then we need to select the settings here. This is set to one sample on demand. Here we have the max and minimum temperature. This is the J couple, and we can set this to built-in. When we are finished with the settings, we can click OK. Next, we could go to the front panel to find an indicator. So you just find a numerical indicator like this. go back to block diagram. We wire the output here, the data output from the DAQ assistant to this numerical indicator, like this. In addition, we need to add a while loop in order to make this logging continuously. Then we find a while loop here, place the while loop like this. In order to stop the logging, we should also have a button. So we find a proper button here in the palette. We could use this stop button like this. Go back to the block diagram and wire this stop button to this terminal on the while loop like this. And next we should add a timer. You click on the palette, find some timing here. We could use any of these, but we choose to use this wait, which we put here. Then next we need to right click on the input, create and constant, and then we can set the sampling time. In this case we set it to 100 milliseconds like this. Now we are ready to run. We find the front panel, we start the program, and then see here we get the values from the DAQ device. You can click the stop button when we are finished. Next we will learn to plot data from the DAQ device. We will learn to create this simple example. Here we have the DAQ assistant. On the block diagram, on the front panel, we have created a thermometer, which just show the value from the DAQ device. Here we have made a waveform chart, which shows the historical data from the DAQ device. And we also have a stop button in order to stop it. So let's start to make this program. So we use the program we already made. Go to the front panel. We find this thermometer here. We place it here. We can make it a little bit bigger, like this. We can move the stop button. We can also find a chart. So here we will find different charts. In this case we will use the waveform chart. Place it like this. Make it a little bit bigger, like this. And then we go to the block diagram in order to wire the proper. So we have the thermometer, we have a numerical indicator, and we have this chart. In order to wire the data to this from this DAQ assistant, we need to find one more function. So we just use the search and we look for it. Convert from dynamic data. So this one, double click on it, find it here, and we place it on the block diagram. Here on this pop-up window, in this case we need to select single scalar value and then click OK. We place this function here, use the wire tool like this to the thermometer, to the numerical indicator, and finally to the waveform chart like this. Then we can go to the front panel like this. We start our program and you see we get the values here inside the chart. In the thermometer we get the value here and also in the numerical indicator. Let's try to change some temperature values and then see what's happening. Now I'm squeezing the device in order to get a higher temperature. You can click the stop button, then you are finished. Next, we will learn how to plot multiple values in a single waveform chart like this. In this case, the blue one is the temperature in Celsius, while the red one is the temperature in degrees Fahrenheit. Here we see the code for this example. In this case, we have used a sub-VI which converts the value from the DAQ device in Celsius to Fahrenheit. And then we have used the bundle in order to bundle these two values to the waveform chart. So let's start to make this example. So we start with this previous example we made. In this case, we have a DAQ assistant, and we have this convert data from dynamic data like this, and then we plot it in this waveform chart. Next, we wanted to add the Fahrenheit values in the same chart like this. So then start to make this sub-VI that convert from Celsius to Fahrenheit. I have already made it, so I just find it here, right click and select a VI, and then I find it on my file system. I place it here like this. And then next we need to find this bundle. Find it here, bundle, we put it here, and then we wire the Celsius values into the bundle, and we wire the Fahrenheit values into the bundle, and then this Celsius value should be an input to the sub-VI like this, and then just remove this one, and the output of the bundle should go into the waveform chart like this. So now we are ready to test the program. We open the front panel like this. We start the program. Then you see in blue we have the values in Celsius, and in red we have the values in Fahrenheit. We stop the program with the stop button like this. Next, we will learn how to log data from the DAQ device to a text file. We will use, in this example, the write to measurement file, which is located in the file input-output palette in LabVIEW. When you place this function on your block diagram, this configuration window will appear. So here you see the recommendation which you should choose. You could save to one file only, overwrite the existing file, save it to a text instead of a binary format. Then here in headers we need no headers. For the time columns we only need one column, and you can use the tabular format to separate the data. Here you see the front panel. We have this ordinary chart where we plot the data from the DAQ device. In addition, we want to save the data in a text file like this. In the first column we have the timestamp, and in the second column we have the temperature data. Here you see the block diagram for this application. We have this DAQ assistant. We convert it into ordinary LabVIEW data like this, and we plot it in a chart. In addition, we have used this write to measurement file. So let's create this application. So we start with our LabVIEW program that we have already made, which we have the DAQ assistant here and the waveform chart here. So in addition, we need to find this write to measurement file, put it here inside the loop, select these settings, save to one file, overwrite file, text file, no headers, one column only for the time columns, and then we use the tabular format to separate the data. Then we click OK. Also here we choose where we want to save the text file. We wire the output from the DAQ device into these input signals on the write to measurement file like this. Then we go to the front panel, we run our code. You see it plots like normal. In addition, the data is saved to a text file. So let's stop the program and see how the text file looks like. Here in File Explorer, I can find my text file like this. I will open it. See here. Here in the first column, we have the time data, and here in the second column, we have the temperature data. Next, we will learn how to use a measurement filter in order to remove noise from the signals. Here in this example, I have used the low pass filter that is built into LabVIEW. We find the filter here in the function palette, express, signal analysis and filter. In addition, I just use this simulate signal in order to simulate a sinus signal like this and add noise to it. And then in this chart we see that the filter has removed the noise from the signal. So let's try this example. Here you see the front panel for this application. In the upper one we have the signal with noise, and here we should show the signal without noise. So here is the block diagram for this application. I use this built-in low-pass filter in LabVIEW, and then we have used this simulate signal in order to get a sinus signal with noise. So let's run the program and see what's happening. You see here we have a sinus signal with some noise, and then here the noise is removed from the signal. Okay, thank you. That's all for this time. If you want to learn more about LabVIEW, please click on this link, and then on this web page you find lots of information about LabVIEW with lots of exercises. Here you find lots of videos, exercises in order to learn basic LabVIEW, and exercises regarding DAQ. In addition, you will find exercises about how to use this USB 6008 DAQ device. Thank you. My name is Hans Petter Alvorsen. Bye.